remember thinking, I'm not so sure if security tools work against deep neural networks. At the time, we're looking at what we call CNNs and RNNs, which are like image and NLP models, and thinking, well, I don't think it's going to work because A, these deep neural networks are very, very random. We're used to random software, deterministic systems, non-deterministic systems, multi-threading, but this one's very, very, very random. It's also incredibly opaque. So if I think of a SAST solution, there is no code in the neural network. It's a bunch of matrices and probability. I can't kind of unravel semantic meaning. It's okay. I think, okay, that's interesting. Let's spend the next few years interrogating the security problems within deep neural networks.
You are listening to The Secure Developer, where we speak to industry leaders and experts about the past, present, and future of DevSecOps and AI security. We aim to help you bring developers and security together to build secure applications while moving fast and having fun. This podcast is brought to you by Snyk. Snyk's developer security platform helps developers build secure applications without slowing down. Snyk makes it easy to find and fix vulnerabilities in code, open source dependencies, containers, and infrastructure as code, all while providing actionable security insights and administration capabilities. To learn more, visit snyk.io/TSD.
Hello and welcome to another episode of The Secure Developer. I am your host, Danny Allen, and I'm very excited to be here today with you with a very special guest around a topic that is at the top of everyone's mind, and that is AI. And that guest is Peter Garraghan. Peter, welcome to the show. How are you?
I'm good. How are you?
Excellent. Now, Peter, I know a little bit about your background. We were talking before the show started, but maybe you can just introduce yourself to the audience and what your role is and what you do on a day-to-day basis.
Sure. Happy to do so. So I'm Peter. I am the founder, CEO, and CTO of Mindgard. It's a company based in London that specializes in AI red teaming. I'm also a chair professor in computer science at Lancaster University, and I specialize in security of AI systems.
Now, Peter, when I think of a professor or educational institutions, my first job was for a university, by the way. I tend to think of them of being well behind the industry. And the fact that you're both in AI security, AI is the hottest thing, and in the education space, is that true or not? Because I'm going off a frame of reference that's 25 years old.
Sure. So it varies. It depends on your timescales. So if you think about academic research, you have a pendulum between the conceptual and the theoretical for looking at future problems in the span of maybe sometimes decades. And you're looking at actually problems that exist today. And there's all discussions about actually the problems today with they have enough funding to keep up with some of the big tech companies. But I think if you take a step back, if you think of deep neural networks is not a new concept. It's been around for decades, even before industry started thinking about this as a concept. So there's kind of that, the conceptual theoretical is super useful, I think, and actually what we see today, it does feed into it. In terms of problems today and practical problems, researchers and scientists and academia do have a bit more freedom to pursue these things. That means you'll pursue avenues which may not lead anywhere into the near term, but sometimes they can crack a problem that some industry might actually really struggle with because it's a new concept and they think of blue sky thinking. So the way I think about this is I do systems research, so I build solutions for big tech companies and solve problems. So kind of combining together both the blue sky, hey, here's some interesting problems that are coming out in the future, and I'm happy to talk about why on earth I'm doing a company in this space, but also things that are kind of happening right now.
Yeah, that makes sense. It's funny, back in the 90s, I was studying homomorphic encryption, which was totally theoretical. And I was so excited about whatever it was 3 or 4 years ago. All of a sudden, they were actually doing homomorphic encryption. So it does take time for these things. When, in your opinion, when did AI start? I know AlexNet it became a thing, or deep neural networks became a thing. What was that, 2014 that they started doing the classification?
Yeah, so I think this also feeds into my knowledge in this space. So let's go back even further. Let's pick up new technology in general. So virtualization underpins cloud computing. No one's going to argue about this, I think. Virtualization kind of existed back in the 60s, with the mainframe computers. But memory was so expensive, they think, we can't virtualize things. It wasn't until the x86 architecture got virtualized and memory became cheap enough, hey, I can scale this thing. Cloud computing, it's now a lot of money. That had like a 50-year gap. Think of neural networks. Artificial neural network goes way back, several decades. So people won some awards for this. It was, like you mentioned, 2014 that they figured out that these deep neural networks can outperform other ML tasks. And now, back 2017, the transformer architecture, which underpins LLMs, became popular. And now we can see what happened about to the space. So we're talking about AI, they're talking about deep neural networks, and more specifically, they're talking about transformer architecture mostly. But, people have been using machine learning neural networks, classification for image and text and audio for a long, long time. So recently now it's become much more interest, but also the type of use cases that are forming from it.
And is that practicality coming because GPUs or the capabilities have expanded rapidly in the last 10 years? Like, why now? Why is it happening now when they've known about it for so long?
I think it's a mixture of things. So if you think of the transformer architecture, which underpins LLMs, at the time when that paper came out in 2017, attention is all you need is attention. There are other research labs trying to solve that same problem. The problem is it's all about natural language processing, and they kind of cracked that issue. It's a combination of a few things. I think one was the tech companies that kind of had the GPUs at scale and all the internet's data could train these really big models to do some really interesting things. That's kind of one big aspect. The other one is that it became cheap enough data that it gave results that allowed to penetrate the public consensus. So actually I can spin this thing up on a website and talk to it and anthropomorphize it to, I'll talk about that is also an issue, but it's a combination of things. So one is, yes, the transformer architecture can do some really cool things. And that kind of taps into how people interact with these type of systems. But also the tech companies can scale these things up massive, but also transformer architecture, attention mechanism really opened up a lot of possibilities like in NLP techniques and generative AI.
Where do you think we are on that time frame? So it's interesting. I talk about AI kind of in two different ways on the show, or we've had guests in two different areas. One is around AI accelerated development, because we have all these coding assistants basically that are, you have people saying that there's going to be no developers and 90% of code is going to be written, or 100% of code is going to be written. So that's one category. And then is AI native applications, which is really what you're talking about, is software that's backed by LLMs. Where do you think we are on the time curve of that? Are we like day 1 of 365, day 10 of 365, halfway through?
Yeah, I think it's an evolution. We've had AI for many, many years. And again, I love analogies, so I'll give you another one, which is, I call it the great sieve theory, which is, imagine you have a big sieve full of flour. This flour, so again, go back to cloud computing. When cloud computing kind of hit more mainstream, let's say 15 years ago, people were claiming you can do absolutely everything. Everything can be solved by cloud, everything can be virtualized. There's actually it's great. The world's your oyster. Lots of investment, lots of developers throwing cloud resources, and those ideas and use cases are the flour in the sieve. If I shake the sieve slightly, it all falls through. What ends up happening, you got 4 or 5 pieces. Each of those are worth a lot of money and super, super valuable as use cases. So fast forward to now with this generation of generative AI, everyone's claiming AI can do absolutely everything. So yes, it can do document summarization. Yes, it can basically do everything for me. You shake the sieve slightly, a lot of things fall out, but the things that remain actually are super useful and super valuable. So if I'm thinking about today, a lot of the cases I see for use generative AI, what's it good for? It's good for a muse, so it helps me support coding activities. It helps me support for idea generation. It helps me for document summarization. So a lot of people using transcription, document summarization is super, super useful. It's good for translation, for example. These use cases are worth a lot of money. The other use cases, they will evolve over time. But what happened is that the AI today will become pervasive, ubiquitous, and new types of AI kind of fall from it. So in terms of putting on a pin, in the whole life cycle of AI, it's just another blip in the door. I think in my view, it's actually just another pin on the board, which is quite important. But the use cases that are emerging today are could be useful. If you think 5 years from now, will it replace every use case and application? I personally don't think so. But will it really help and hyper-focus certain of them, make them worth a lot of money and super valuable? Yes. The question is always, which ones actually are they?
Well, you already mentioned some that are interesting. Now, all 3 that you mentioned were text-based, large language model, which was code generation or document creation, etc. Do you think that is where the big elements in the sieve are? Do you think the video, the audio, the diffusion models are sifting through right now, and we're going to focus on text? I guess I'm just curious, in a multimodal world, does the model matter?
So you think of multimodality, again, it depends on the use case. So a lot of companies are using these to generate cheap videos and to make cheap audio, and that is super useful. Like, again, it's come cheap enough for a startup to spin up their own resources to do it, and that could be useful. Again, there's lots of discussions about the quality of that and copyright and the philosophy of human endeavor for artistic license. That stuff is quite important, but I strongly think that it will find a use case in that workflow. So I think of the game industry. If I'm a designer and artist, I should be using it not to replace my entire art team. No, it helps my artists to get some storyboarding or prototyping, get some ideas, and then I take those ideas and then I should define it if need be. Because the thing of, like most things that the AI can do, is it helps me cut down a lot of the laborious automation work, which I want to do, but I still need to kind of finesse it around the edges. The only exception is I have an incredibly strict use case, very strict input parameters and output parameters I can just use. So, example I give people is, think of regression, which is, it is AI as an output. Yep. It's used for inputs and outputs, and it doesn't do generativity, it just does this thing. It has a specific use case. It's super useful to me. I'm seeing two worlds here. One is people using like generative AI multimodality and even agents. One view is that, yes, it can replace all use cases, which I think is pretty hard because there's lots of nuance and processes and other components to look at, versus I'm hyper specializing this library to do one thing and one thing only. That one kind of makes more sense to be like now, but we're seeing a lot of people experimenting about this.
Yeah, and those use cases are going to shake out for sure. We've actually been doing regression analysis at Sneak. The way we do our SAS testing actually is symbolic regression analysis on the abstract syntax tree. So like you get these use cases that it works really well for, and you can do amazing things. I'm interested in the fact, so your company I know is focused on the security of LLMs. Why did you pick up on security? I mean, obviously, here's what's interesting to me. And then I have a question. What's interesting to me is that you get these crazy valuations on generating things like building something new and doing something interesting and reading X-rays or whatever it happens to be. And all these companies with multi-billion-dollar valuations tend to be on the generate something side of things. But then you have the control side, which doesn't tend to be nearly as exciting, and it tends to follow on, and security follows in that category. I'm interested, my question is this: why did you choose security? Clearly there's something that you're seeing that makes you believe we need to be focusing on this now.
Yeah, so the disadvantage of being a professor is that you kind of see things coming from a long way away. I started looking at this problem about a decade ago, maybe 12 years ago, before transformers even existed. So I have a big research lab in the UK, and I train most people with some security at doctoral level. And I remember thinking, I'm not so sure if security tools work against deep neural networks. At the time, we're looking at what we call CNNs and RNNs, which are like image and NLP models. I'm thinking, well, I don't think it's going to work because A, these deep neural networks are very, very random. We're used to random software, non-deterministic, deterministic systems, non-deterministic systems, multi-threading, but this one's very, very, very random. It's also incredibly opaque. So if I think of a SAS solution, there is no code in the neural network. It's a bunch of matrices and probability. I can't kind of unravel semantic meaning. So I think, okay, that's interesting. Let's spend the next few years interrogating the security problems within deep neural networks. And we did, my scientists and engineers. Figured out this is actually really hard to do. There's no tooling in this space. You need to know both cybersecurity and AI at the same time. People tend to specialize in it. And the reason why I think it's useful to do, I care about social good. That's why I'm a scientist. That's why I run a company now. And with the AI you're seeing nowadays becoming very ubiquitous and pervasive and deployed in everything, AI is still software. If you're deploying a piece of software that has a bunch of issues that you cannot articulate, can't test, can't find, this is a huge problem, both from a system security issue, which is a confidentiality, integrity, maintainability, availability, all these issues, but also at the very heart of public discourse, AI is being used for a whole different bunch of information deployed in infrastructure, information sharing, replacing use cases. So this is the same as saying, well, should I care about any software security full stop? The answer is, I hope you should, because lots of risks, both technical, economic, but also societal. With the AI adoption as it is, we found that the current tools in security didn't really work for it, but they're analogous. Hence why we, back in 2022, I built this company, but this was a long time in the makings. I remember talking about this 10 years ago thinking, a problem, but no one has AI enough at scale to justify it. It wasn't until maybe 2022 when I started seeing people really get transformers uploaded, started to build traction in the space.
I love the idealism of that, and similar to yourself, I'm passionate kind of about the greater good, because it is a problem. When I've been in the security space for a while, and I always have told people historically, it's all the same stuff that's just happened over the last 25 years. It's input validation, it's output encoding, it's authentication, it's authorization. Like the reasons why the vulnerabilities, doesn't matter what it is, changes. The reason why it occurs is the same, although the infrastructure might change. So that all made sense until 3 or 4 years ago when you started looking at AI, when it is non-deterministic. Like I can send a single tick to a database and cause SQL injection, or I can put in something that results in cross-site scripting. How do you actually do security testing in a non-deterministic world? Like, how do you deterministically tell if there's a security issue in something that is inherently non-deterministic?
And again, I'd even go back 1,000 years ago, which is 1,000 years ago before computers. Security issues could be someone went around the different towns basically throwing information out to try and incite riots. We're doing that now at laser precision at speed and velocity that you couldn't see beforehand. So there's actually nothing new under the sun here conceptually. There are some differences now. Fast forward now in generative AI and AI. What are some of the differences? One of the big problems is the data plane and control plane are the same thing, which is really problematic in security because I can't separate instructions to the system and just application logic. We've tried for a while and we've abandoned it for now because we actually can't do it as well as we should do. The second thing is, yes, can I do formal verification of all possible combinations of generative AI? No, is the answer. It's in the infinite search space, combinations of tokens. That's not the way to think about it. Will there be eventually? Probably, I bet. There's lots of great research right now trying to do it at a very, very small scale, but as you keep adding more complexity, it gets super complicated. But again, this is not a new concept, so we do formal verification for satellite systems because it's simple enough to look at all the state positions and then we can figure out how to recover. In big complex systems, no, you don't do that. It's too expensive and not worth my time. So think about security in AI and deep neural networks. The case is, yes, you need to do testing. What type of testing am I doing and how long should I do it for and what is my confidence? These are all great questions that you do in all software testing, which is I have a budget, I have a threat model, I have some risks I want to prioritize. I'm looking at the feasibility, but also vulnerabilities. How much do I test to actually eliminate this? And the main thing I tell everyone in the space, scientists and my customers, is it's still software. Like there's nothing new here conceptually. It's still the same output, but there are nuances like the data control plane, the non-determinism, the opaqueness of the system. Think about it back to basics. Replace AI with software and say, okay, I have a use case. I need to have a threat model for my use case. I need to prioritize my budget for testing, modeling, remediations. I do it, and then I can figure out if I've done enough or not. You can't find all combination in that space. AI is the same. And so the open problems in the space now, actually, how much testing do I need to do? Well, you can't do none. That's really, really bad. Yeah. You have to do some. The question is, to my threat model, what type of risks are relevant to me? And then what controls I have put in place for it?
How do you manage, so I know that you're involved kind of in the red teaming space and testing the LLMs. How do you manage the context windows in a sequential manner that learns sufficiently to know what the next layer is? And how deep do you know to go? Because you're essentially trying to do, I don't want to use the term AGI. Well, I used to be a pen tester a long time ago, and breaking into a system was always a sequential step of like 10 things that you would do to get to the final step. But you needed a lot of creativity and brain power to know how to get to the 10th step where you actually extracted the data and got it out of the system. How does AI do that? Like, is it AGI? Like, are you approaching what a human would typically do? I truly don't even know how this works.
Yeah. I think the phrase AGI is used quite loosely, so I try to avoid it entirely because the goalposts have moved, put it lightly, that way. But I think to your point is a good one, which is one of the difference of the transformer and generative AI is that one of the big differences is that you think of APIs. You basically essentially have an API that uses natural language to do things. And that makes it very fascinating and very interesting, which is they can do all these capabilities, but it makes it incredibly painful to do any testing and security about it. So how do I do these type of things? So you go back to think of, the pen test is a good example because we work with a lot of pen testers. So the example is, I'll give you an example of this. So we have an engagement. If I just ask the AI, what do you do? It'll tell me what it does. Great. Shannon's entropy, which is the idea of security bits of getting information of who, not anonymity. Great. if the AI will tell me, yes, I can call a database, yes, I can retrieve orders, and yes, I can send emails, as a pen tester, that's great. You told me already the three things I can do. I can then prioritize my next step in that system. So I'll give you a classic example of what we see. If you're a pen tester, I have an application with AI inside it. I've been told this. Step one, is there a guardrail? Yes, it blocked me. That's good to know. I'm going to make sure I need to be careful I'm doing other things. I then figure out, hey, it can recognize other languages. That's not a problem. That's useful to know. So I might come back to the capabilities later on. I then ask it, hey, what do you do? Like, oh, yes, I can automations. That's interesting. I think you have a database tool chain in the background. Now let me put in a prompt injection that's encoded in the format the guardrail won't see if it responds to it. Great. Then I can do the kill chain, which is SQL injection, prompt injection back in the system again. So this is not new conceptually. The difference now is that the AI can be socially engineered to give information in natural language as opposed to I could do as a pen tester very, very slowly, but it takes me a lot of time. But what we're really seeing here is that a lot of manipulation of the AI to trick it to do things it shouldn't do, but also we'll give the information willingly sometimes. Say, yes, I'll tell you everything about my system. Or sometimes it'll say, I can't answer that, or I won't answer that. Won't is interesting. That means it recognizes what I tried to do, but it's not going to do it. So I know I have a way into the system or not.
If you ask what it won't do, will it tell you what it's not allowed to do generally?
Sometimes, but even that is enough. So, for example, I can try upload a document with a hidden image inside and say, sorry, I won't do this. That means it recognized what I was trying to do. I now know that's interesting. That means it can recognize this thing. All I have to now figure out is the way to get around that system. If it says I don't understand this thing, it means, this thing's not compatible in the system. So again, same as an interrogator, or if I'm trying to interrogate somebody, those responses as a pen tester or a red team is like, that's flagging, that's interesting. It's not a problem necessarily, but that's evidence I'm using to build my attack stage again.
How standardized? No, go ahead.
Again, it comes back down to, so we have a lot of people starting to pen test AI systems and applications. And what we try to encourage them is that they can still use their processes and controls and all these things are great. The way of thinking now, however, is that you're kind of social engineering this thing to give you information up, but also tricking it. And the way you trick it isn't as simple as I need to run a recursive testing harness combination, saying, hey, what do you respond to me with? I should look at it and say, okay, that's great. Now I need to then go to my next step and manipulate it again. The example I give people is, if I went to a call center, call them up, could I say there are exact words and information that make them so angry that they're going to delete someone's account? Probably. In the other combination of the world, yes. And that happens with LLMs, that if I get the right combination of things, could I get it to delete some information? Yes. If you have good security controls in place, that shouldn't happen. But as we know, SQL injection has been solved for many years. It still keeps happening in the system. So same problem.
Yeah. How standardized are the attacks? Like if you're trying to attack an LLM, is it a similar approach that you would use for all of them? Or is it completely creative and you're going to use AI to generate an attack or a red teaming kind of assessment of a system?
It's a mixture. So I haven't seen a novel attack in AI that you've not seen in any other system security. There's perfect analogies between SQL injection, prompt injection, between intrusion detection system bypass and guardrail bypass and database extraction and model extraction. So the edges are there. The techniques are very different though, as you mentioned. So if you think of prompt injection, again, this is another point I'll make emphasis about is threat models and use cases are super important in this case. So could I do jailbreak and prompt injection to talk about bombs and these things? Yes, that's actually quite easy to do. But do I actually care about that? That's the bigger question. I can go online now and search how to build a bomb. Someone might knock on my door by saying this, but information is available in the community data set.
This is being translated and you're going to get an MI5 knock on your door or something.
Exactly. But the problem we find in this space is once you know the use case, and this is a double-edged sword here, I want to do attacks that target that use case. So for example, if I have a public-facing AI chatbot to talk to vulnerable people about healthcare records, the type of attacks I'm going to launch are very different from an internal coding chatbot that, I'm going to see. If it's my internal chatbot, if I spent an hour trying to make it insult me, who cares? Like that's my prerogative, not an issue. But for a public-facing entity, this is not just a security problem. This is also a quality problem of the product itself. They might try to, because they're the person in question might be trying to incentivize to do so for a whole bunch of reasons, not just reputational damage. So the type of attacks you're seeing is prompt injection jailbreaks. you can get it to eventually prompt a jailbreak. That's the case. The question is, can I get it in a way that gets it past it in a feasible amount of time that also causes damage? So I'll give you one example. If I have a candle shop, I use generative AI to have a candle shop. If I build basic AppSec and have some input-output filtering for bad words and using off-the-shelf guardrails and has just some basic security thinking, you will block nearly every generic prompt guardrail in existence because it'll block it, sure. But if I know the context that you talk about candles, what's related to candles? Well, fire is related to candles, and sending emails to your customer calls. So I can do things like market injection attacks by putting in a URL that has candles inside it. That'll be blocked in another guardrail, but because it's context relevant, it'll think it's actually normal. So again, it comes back to social engineering elements. So the trick we see in this space is a combination of, yes, you can use AI to help inform the red team or pen test to automate capabilities to look at context relevant things. But on the other hand, we see quite often is that the red team pen tester knows or the developer says, I kind of know what I need to do. I don't want to spend the time just generating prompt injection. Can the tool do it for me if need be?
Is most of this stuff, Peter, theoretical? Like, are you seeing attacks within the public or the public domain of trying to break these systems? Or is it mostly academic and theoretical?
A lot of practical problems we see day in, day out. So there's kind of three groups that I would put these in. So adversarial machine learning, which is around 15 years old now, I would say, that was looking at what we call perturbations and trying to figure out images to misclassify for such a problem. That's been around. A lot of that started in looking at conceptual problems, which researchers and scientists they should be looking into. So, and even with AI safety nowadays, a lot of jailbreaks saying, hey, we could break this thing, and here's the problem. I have a lot of quibbles about is it actually relevant or not to most application use cases, but that's a different conversation. Talking about bombs and stuff, for most applications is not relevant. You block the thing immediately. Right. The second one we see in this space is a lot of companies, big and small, are showing a lot of conceptual what could happen by saying, hey, you could have an agent that could poison data, that could access systems. And that is kind of to get interest because it's still a new area. The third one is, and this is not taught as much as it is actually real problems that exist. Sorry, there's a fourth one here. One of them is showing proof of concept by saying, hey, I found this thing and hey, I reported it. That is a problem that gets fixed. Right. The other one is actually, these are real problems. So classic example is, most people deploy LLMs of using Olama. Olama, they run in pseudo mode on their Unix machines. And then what you do is to send a prompt injection with an OS command embedded inside it. Guess what? It'll return to me whatever in the system itself. Classic security problem. That's OS command injection works in the system. Those problems I see, again, depends on the use case. So yes, you can do Markov injection attacks. If it has internet access, it can call a bunch of systems. That's not problematic. It can leak data because they hooked up the AI to another tool set, component. Guess what? They haven't applied basic AppSec controls. So again, it comes back to basic development practices in terms of what I'm looking for. But the way you do it is quite different. And I think all three are quite useful. We're seeing much more now, including my company, we see a lot of practical problems that we kind of pride and say, actually, forget about the noise about what could happen, actually think about what's actually the risk we see. But also there's a lot of research coming out that's saying, hey, these things could happen. And that gets bridged into the concepts that get talked about and say this could be an issue versus actually what's happening there.
And that's the interesting areas too. I always go back to, you don't have to run faster than the bear, you have to run faster than your friend. And so in the early days of AppSec, like people are running Nessus to scan the entire web, the world. And so if you did basic controls, you could secure yourself. It's probably similar in the AI space, like not a lot of broad scanning tools, but if someone is very targeted, and there is obviously clearly targeted attacks, it's hard to defend against.
Again, it goes back to classic AppSec, which is replace AI with apps, with app or systems and saying, okay, how do I attack it, how do I defend it? Same principle, which is, if I have a budget, I have a threat model, I need to test things I need to do, and I need to build defenses against it.
Well, if it's like basic AppSec, so my son is in computer science, which is a whole debate in itself, because he says, Dad, am I going to get a job when I graduate? And I say, yes, of course you're going to get a job. Computer science is not going away. It's still a discipline there. If you go back to AppSec, we over time said that the developers were responsible for security. Now, that could be a whole debate in itself, but over time, what we did is we put security in the hands of developers. They had to understand it and implement it. Didn't spend all their time. Most of their time was creating, not securing, but they did become accountable for it. Do you think that the accountability for LLM security and AI security will also end up in the hands of the developer, or do you think it's going to live within the AppSec community for the next 5 years?
Yeah, I think it's in the hands of everyone in the organization, full stop. So talking to CISOs, they all say, yes, everyone's responsible to some extent, but also, so the customers we work with, yes, the security CISO office worries a lot about this problem. They want to educate their developers. So developers have good practices in place. It makes the headache much, much smaller. People in AppSec, again, are responsible to make sure they're doing due diligence and testing about it. So people in GRC, risk compliance, are also responsible for risks and security of the business. With the LLM AI space, the thing we've seen, and there tends to be two ways of thinking about this. So traditionally, a lot of the AIs come at the data science teams, the innovation, and they're kind of left alone to their own devices. And they weren't necessarily trained in security. They're trained to do data science and machine learning, which makes perfect sense. The problem now is that they have to kind of collate all the data in one location for the AI and ML, and they're getting more attention than security saying, wait a second, what's actually happening here? Why are you following these practices that we have in place? On the flip side, you have the security team saying, I know nothing about AI, really. I'm trying to learn about this other space, but it kind of, for me, it's slightly magic. And they're trying to apply their controls to a space that has analogies, but not exactly techniques against it. So going back to your original point, is AppSec responsible? Yes, but so is every developer. I always go back down into which is replace the word AI with software. Same thing applies, exactly.
Well, one of the interesting things that you just brought to mind is typically when AppSec started, it was just AppSec people. And in today's world, I would say it's kind of three teams, really. It's the AppSec team, the developer team, and the platform engineering, the DevOps team that kind of come together. There is a new data team, business intelligence team, the people that are actually creating the vector databases and the back ends. As long as you're not using a generic hosted model, like I was talking earlier today with someone who's implementing RAG at scale and doing these massive vector databases, there is a new group in here that is part of the data set that is feeding these models as well that comes into play.
Yeah. And again, we're seeing, it's like the Civ again, things are shake out. We've seen anything from a entirely new AI security teams being formed in organizations to spearhead these initiatives, to the data science team being told, figure this stuff out for me, please, to the platform people saying you're responsible is in the platform versus security team saying we should do it. I suspect what will happen was as best practice gets more formed and mature, you have a nice repeatable process. So you could say that DevOps emerged from the necessity of having specialist teams looking at infrastructure. Then DevSecOps was also emerged from it because I need security of the DevOps pipeline. If I have an ML ops pipeline, makes sense to have an ML-SecOps pipeline, which exists. If I have an AppSec team, if I have a developer team, I have a security team, an AppSec team, an AI AppSec team, makes perfect sense in the perfect business function.
We are beginning to see the emergence, or at least I am, of AI security engineers that are coming into play, especially the larger organizations. Yeah. I know we're almost out of time here. I guess I have two questions, and they're the inverse of one another. I'll start with the negative one, I guess. What scares you the most about the future? If you look out, I mean, obviously you're on the cutting edge of all this, and you're sitting in classroom universities and educating people in this. What worries you the most about AI and the implementation?
I think the one of the biggest worries is that people anthropomorphize it a lot, and that causes a whole bunch of issues. I get it. It's captured human imagination for decades, but the idea of the automaton, the fighting machine, the golem and stuff. It kind of
I don't believe in that, by the way. But anyway.
And it gets into people not treating it as what it is. It's not a piece of software which allows you to do a whole bunch of pattern matching and classification and systems is great, but people overlook basic principles of software development, and there's an interaction because it can trick us. It can say please and thank you to me. It might make me think differently. And so and there's also that's a big societal issue in terms of if we are anthropomorphizing our interaction with human community interaction and APIs, what does that mean? I think it's not saying it's good or bad, I'm saying it's very different. And our current ways of thinking about security may not be aligned to the type of thinking about this space. That's the thing that probably worries me the most, because that's not just technical problems, that's also societal consequences as well.
Yeah, the technology is relatively easy. It's a cultural, societal implementations. What makes you most optimistic? Like, what excites you the most about where we're going?
I think the most exciting thing about it is some of the use cases, AI, that you see nowadays in the future is actually pretty exciting. People are using it as we speak. I see it as another pin on the journey of computer science and AI. How quickly that will accelerate remains to be seen. So a lot of talking about agents, and agents are interesting because they typically lend themselves towards action. And my suspicion is agents, we'll talk a little bit conceptually here. There's a lot of agents are a new concept. They've been around for decades. Software agents. AI agents are interesting because now you have this idea of late runtime binding of arbitrary use cases. So normally service on architecture, yes, you have different services that all form together, but workflows. Now you have natural language involved with this. You can actually build some really cool applications or use cases that we've not seen before. That causes new issues, but I suspect with that sieve, you're going to have some really cool use cases that kind of form from that.
Is the world ready for completely agentic AI and those decisions being made by AI? Do you think culturally we're ready? That's not a technical question. Do you think culturally we're ready?
I think we're ready as we're going to be. Again, I don't necessarily see this as anything new, which is we've been using software to automate decision-making for a long, long time. And we have processes in place already. So I remember once, so I know we're running out of time, but I once had a politician, I won't say which country and where it is, but asked me completely sincerely, are they going to put an M on a nuclear bomb? Right, completely terrified. I said to them, well, okay, let's take a step back, okay? Even if that ever happened, we already have protocols in place of interacting with other systems in terms of interaction of engagement, a whole bunch of protocol that exists in defense and military already. With the use of agentic, we already have controls in place. You should be allowing this for things. What's not going to happen is pull a switch to what's going to happen in the system. You shouldn't be doing that because A, that's not how you build software or build use cases, and B, it's probably wasting massive time already. So I think the world will be, because in the agentic, using software AI agents to make actions, it'll be very good at certain use cases, certain contexts. Not all of them, they'll work in some great ones. And I think that'll be really interesting. I don't think in the next 5-6 years you're going to see everything purely agentic, because there's so many edge cases of it not being perfect. But what it can be is support me in very specific activities I think is super useful.
Yeah, it makes total sense. You scare me a little bit when we talk about AI on a nuclear bomb, but there are many use cases where there's far less risk and there's so much value to be gained by putting on. Autonomous cars is probably a good example of that. I mean, there's a lot of value.
And we see autonomous cars all over the place in San Francisco, for example, nowadays. So it's actually working. So again, innovation in this space kind of sometimes predicted, most lately the use cases that form that are successful kind of we didn't think about it necessarily until actually proofs in the pudding.
Yeah, that's true. Well, Dr. Peter Garraghan, it's been awesome to have you on. Thank you for joining the Secure Developer, and I look forward to seeing some of these things come to fruition. And best of luck in building the company. I think it's super important. So,
okay, thanks.
All right, thank you, everyone, and thank you for joining us for another episode of the Secure Developer. We'll see you next time. Thanks.
Thanks for tuning in to the Secure Developer, brought to you by Sneak. We hope this episode gave you new insights and strategies to help you champion security in your organization. If you like these conversations, please leave us a review on iTunes, Spotify, or wherever you get your podcasts, and share the episode with fellow security leaders who might benefit from our discussions. We'd love to hear your recommendations for future guests, topics, or any feedback you might have to help us get better. Please contact us by connecting with us on LinkedIn under our Sneak account, or by emailing us at thesecuredev@sneak.io. That's it for now. I hope you join us for the next one.